mainly about graphing things, and we did a big review on all the different types of polynomials, so linear, quadratic, cubic, different polynomials. Typically, polynomials were word problems of some sort, and typically you had to do something with your calculator. So this question, which said the height of a rock being thrown from a tree fort can be modeled using the equation, then they give you the equation, where h is the rock's height in meters and t is time in seconds. We had to graph this equation right here. And then we had to set a window. The window settings are on the side. So you'll see I've put my x min, my x max, my x scale, everything over there on the side. And it should have given you that nice little graph right there. To find the maximum height, which is part A, you had to find the vertex. To do that, you go second, trace, and then maximum. Then you go left of the maximum, hit enter, go right of the maximum, hit enter, and then you find it. We're now on part B. So part B is when will the rock reach 10 meters? Honestly, with word problems, I think it's super smart to write down what you know and what you don't know in terms of the question and the variables. So we know that h is height and t is time. That means in every single question, they should give you one and ask for the other. In this question, it said when. When is looking for time. That means they must have given me h. It's pretty clear on this one. When will the rock reach 10 meters? They told me h equals 10. That might seem tedious, but when you get to a problem where you don't know what they've told you or you don't know what they're asking, then doing that might help you a lot. I know one, I don't know the other. They have to give you that info. There's no way they can leave both out. It wouldn't be possible. All right, if they gave me an h value, h is my y. Erase that. So what they've really done is they've given you another y value. To solve that, you make this a second line in your calculator. Now, I know you guys haven't graphed this. If you have it from yesterday, that's awesome. You can just graph it. If not, you just have to follow along. So when I graph this, I get negative 4.9. X squared plus 100. Y2 is 10. I'm just changing my window quickly so that it fits. I should get that nice graph, but now it has a second line through it. And that second line is right about here. When I'm looking at my graph, the green graph represents my rock being thrown. Right? And that's how it falls. The red graph is just showing me all the places that you have a height of 5 meters. It was 5, right? Your job is to figure out when the green rock is at that height. You're trying to find this moment in time right here. In math, especially on our calculators, we call that an intersection point. To solve for that, you go second, trace, second trace, and your fifth option is intersect. Second trace, intersect. It brings me up to my beautiful graph. It says first curve. Don't use your up and down arrows, okay? Move your left and right arrows so that your cursor gets close to the intersection point, my little blue star there. So I move my arrow pretty close to it. Doesn't have to be spot on, just close enough. And then hit enter, 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 and it'll tell you on the bottom that that star point is happening at 4.29, 10. That means at a time of 4.29 seconds, we have a height of 10. And now I can answer the question of when will my rock reach a height of 10 meters? It'll reach a height of 10 meters at 4.29 seconds. That's how you solve for an x value when you've been given a y value. Awesome. C, when does the rock hit the ground? That's a good question for our strategy of write the two things. You must know one of them you must be looking for one of them. So if I read this, when means time. When does the rock hit the ground? Well, they never gave me a height, right? They never said, hey, the height is 10 meters. Yeah, why would it be 0? When it hits the ground. So it's up to you to kind of interpret when the rock hit the ground is 0 meters. A perfect question where you don't know one of the pieces of information, right? Like you think you do, but you don't. No, you think you don't, but you do. And the best way to figure it out is to write out what they wanted. So write out what you want to find, because that means they had to have told you the other thing. When in doubt, just make it 0, because that's probably what it is, in all honesty. So in this question, because the rock hit the ground, our height is 0. What you're looking for now is this moment in time where the rock hits the ground, my new blue star. That's known as an x-intercept, right? There's 2 ways that you could find that thing. Way number 1 is you could draw a second line at y equals 0, because technically you do have a height of 0. The other way, which is probably easier, is just to find your x-intercept. To find your x-intercept, you go second, and then trace, and then you don't do intersect, which is what people like to do for intercepts. You go second, trace 0, which is your second option. Second, trace 0. It then says left bound, right bound. You want to go left of your x-intercept, right of your x-intercept. You actually have to go off your graph if you use the same window as myself. You hit enter both times, and you end up figuring out that that's 4.52 seconds. So the rock hit the ground at 4.52 seconds. As much as my questions don't always make the best of sense, and sometimes they can be a little bit unrealistic, like this treehouse being 100 meters in the air, the diploma exam does a pretty darn good job of making their answers be realistic answers. So if I throw a rock, it shouldn't hit the ground 300 seconds later. Like, nobody's doing that. You should have a realistic answer. And I think 4.5 seconds of a rock being in the air is kind of a realistic answer. The reason I say that is sometimes it's good, especially on numeric response questions, to just ask yourself, does my answer make sense? Right? Or is that a completely unrealistic thing to happen? All right. This guy. If you remember, the polynomials unit was the first time that we started to really get into something called a regression. A regression is when you get given raw data and you need to turn that into an equation that best fits that raw data. This question is a regression question. I know that because I'm not given an equation, but I am given a bunch of info, right? A bunch of X and Y info. That did not work out. That was a star. Remember that sometimes they can give that info in funny ways. Like we've seen graphs before where they tell you a bunch of points on a graph. That's them giving you X and Y values. This is giving you X and Y values. Beautiful. So the first thing we need to do is take that information and turn it into an equation. It says right here, create an equation. As soon as you read that word, it's like, okay, I'm doing a regression for sure. Don't be creating equations off the top of your head. Probably won't work out. How a regression works. It's been a while. You are going to click Stat, which is right here. The very first option under Stat is Edit. So you hit Enter under Edit. And it's going to bring you to 3 columns. It should say List 1 or L1, L2, L3. You want to make sure there's nothing in those things. If there is, like for instance, I have a bunch of things. If you go up top, move your cursor. So mine's now on L2. If you hit clear and then down, it'll clear everything that's in that list instead of having to do one thing at a time deleting. So clear everything out in your lists. Beautiful. In L1 is going to go your X values. If there's time, it's almost a guarantee that X values is time. We aren't going to put 1970, though, as our first time. We're going to put the year 0 as our first time. And the diploma does, I believe, remind you to do that most of the time. It'll say, starting with this year equaling 0. And it tells you that.
Is it really?
Yeah. And on your unit test, it'll be small writing in brackets, but it'll usually give you a hint. And it'll say the year 1970 equals 0. And then they'll usually give you the second one. The year 1980 equals 10. And then it's up to you to figure out the rest of them. That means the year 1990 is 20. The year 2000 is 30. And the year 2007 is 37. Whoa. So you need to put those into your list 1. 0, 10, 20, 30, 37. Just for the record, what those numbers represent, like 10 means 10 years after my first number, which was 1970. Your Y values, you do put in however they have them. So I do understand that it said that the consumption was in quadrillion BTUs. You do not want to convert those to quadrillions. Put them in the way you see them. So it's going to be 12.4, 21.8, 20.4, 19.3, 22.6. You should now have everything in L1, everything in L2. All right. That part people usually are good at. My advice to you, regression problems are almost exclusively numeric response problems or written response problems. They're almost never multiple choice problems. So, being the paranoid individual I am, I double check that my numbers are all accurate. If you miss one decimal place, you will have the wrong equation. Okay, so I double check 12.4, 21.8, 20.4, 19.3, 22.6. My numbers are all correct. Take that 10 seconds to double check. Beautiful. You've now told your calculator the raw data you have. You need to then ask your calculator to turn that into an equation. To do that, you're going to go Stat. You're going to click the right arrow over to Calc. And there's a whole bunch of regression models there. So if you start at number 4, you'll see number 4 is LIN reg. That means linear regression. Number 5 is QUAD reg. That's quadratic regression. Then we have cubic regression. Then we have quartic regression. Then we have another linear regression, which we never use that one. Then we have a natural log regression, LN reg. And then we have exponential regression, which is EXP reg. You have to choose the right regression from that list. If the question tells you the regression to make, do what the question says, no matter what you feel about it. If it doesn't, for instance, this one just says create an equation. It doesn't say create a linear equation. Then I have to choose the right one. The way I choose the right one is by looking at the Y values. So my Y values, I start at 12. From 12 to 21, I went up, and significantly up. From 21 to 20.4, I went down, but just a little bit. From 20.4 to 19.3, I took a bigger dip, so it went down again. And then from 19.3 to 20.6, I significantly went up. If I was to imagine how this looks on a graph, it would go up, down, up. And then you can tell by the shape of what you just made the type of equation you should probably make. Yeah, what would make that shape, Hazel? Yeah. This thing is a cubic pattern. You could make a little graph and plot those points and then be like, what shape does those points make? But honestly, I think just following the trend's the best way to do it. And it's by looking at the Y values. The other thing that's important is that trick only works if the X values are always going up. Notice that my X values were in order. It was 0, 10, 20, 30, 37. It was always going up. If my x values are all over the place, that trick doesn't work. Awesome. Cubic regression. A cubic regression is number 6. So I'm going to hit number 6. If you have an older calculator like myself, it'll just say cube reg on my screen right now. Okay, so if you have an older calculator that says cubic reg, just hit enter. If you have a newer calculator, it brought you to a menu of things, correct? I believe it says like X1 or list 1, X1, list 2, Y2 or something like that. And then it says store reg, STOREREG. Remember, that's where you can tell your calculator to take your regression and put it into Y1. So if you want to do that, you go down to store reg. And then, does somebody have one of those calculators? I can just see it. Yes. I don't know. You're going to go vars, VARS, over to Y bars, hit enter on function, and hit enter on Y1. Oh boy, sorry, I screwed it. There you go, back to the list. So if you want to try it, go down to store reg, you go vars, hit right arrow to Y vars, hit enter on function, hit enter on Y1. Your calculator will now automatically graph your thing for you, which is wonderful for those newer people, calculators with newer features. So you have your calculator. Do you have one that says that?
Is the newer ones the older ones?
Yeah, no, you know. You're like, all right, no matter what, so then you guys go and hit enter. You should have this equation pop up on your screen. It says A equals 0.0015845834. B equals negative 0.0982548215. Should say C equals 1.7427866495. And it should say that D equals 12.44168052. If you get an awful one like that, you do have to use every decimal value there. Do not round any of them. Unless it specifically tells you to, don't round. The good news is when they do regressions on the diploma, they're almost always really nice regressions. So the answers are like 2.5, 0.1. Like they're actually pretty nice. I can't come up with regressions that come out that nice. So we've got a few. I usually use them for tests. And I just need to work on making nicer ones for you guys or steal them from somebody who's already made them nice. One or the other. Awesome. What they've done is they've given you an equation now that models our situation. And it's a cubic regression. So that means that's a cubic equation where those values all match up with something. A is the number that goes in front of x cubed. B is the number in front of x squared. C is in front of x, and D is in front of D. You don't write your answer like that. You actually need to write out the equation. So just to save us some time, I am going to round, but you should not. Okay, so this would be, oh boy, I have no room to write it anywhere. Look right here. This should be y equals a different color so it stands out a little bit more. 0.0015, I'm going to say 6, x cubed minus 0.09 x squared plus 1.74 x plus 12.44. Sorry, it's messy. I didn't really have room and I couldn't fit all those numbers if I wanted to. Do write out the equation. Don't just write the values. Yeah.
I don't know, you might have already said this already. I'm sorry if you did, but if unlike the diploma, on like question A where we have to like write it out, are we allowed to like round when we're writing it out?
You shouldn't have to because they give you good numbers. So like it'll work out perfectly. But if you do have to round, they'll tell you what to round to. And if they don't tell you what to round to, don't round. So if it doesn't say round to the 10th, round to the 100th, then write out the whole shebang. But that's why they give you good values, so that you're only having to write out 2 numbers and then an x squared, and then 1 number and then an x. Right? They keep it pretty straightforward. I think the last one they did, there was no decimals at all. It was like 247, and then it was like x squared or something like that, and then it was a +2. Like, it was so nice. So they do typically give you ones that fit really well. Yeah, for sure. All right. We can now use that to predict things. Okay, we can use it to interpolate. That means pick or estimate values that are within dates that we actually know. Or we can use it to extrapolate, which is guess Y values for information that's beyond what we know, like the year 2020 or something like that. Whoa, 2020 is this year. Like 2030, something way in the future where people have flying cars and stuff. So this question says, according to your model, our model is the equation we just made. It's not looking at the data and guessing. Okay, it's using this equation that we just made. What is the consumption rate in 1992? Remember, they should always give you an X, ask for a Y. They said, what is the consumption rate? That means we're looking for a Y value. That means they must have given me an X value. X is my time, but it's not 1992. It's 22. Because remember, we changed everything to fit our model a little nicer. Instead of putting our years, we put 0 and then 10 years after that and 20 years after that. So X is actually 22 here. The best way to solve this is probably by graphing it, which is what we're going to do anyway, because we're going to need it for part C. That's definitely how you solve part C. You could technically take that X value, put it in your calculator, and calculate that big number, and it would tell you the Y value. But I think it's easier just to graph it in our calculator and then look at it. So the first thing you want to do is put Y into your Y1. There is, for those of us with an older calculator, you can do that quickly without having to type it all out. So if you want to not have to type all those numbers in, you go to Y equals. Under your Y1, you're going to click vars. Down to option number 5, which is statistics. So this is for people with old calculators like William Brooks, right? So you're going to probably want to follow along, so this will save you some energy.
I did that.
You did this? Beautiful. So you go 5 on statistics. You did that? All right. And then you go over to EQ, and you hit enter on reg EQ, and it'll put it all in for you, which saves you having to type it all out. Much, much better. Word. You're ahead of me. You're ahead of the game, man. I called you out for no reason. It's all my fault. Beautiful. Window. You always have to set a window that makes sense to your question. The beautiful part of regressions is your window should be pretty easy to set because they gave you information. Right? X minimum. Look at the data they gave us. The minimum X value we use is 0. So X minimum is 0. X maximum, the maximum year they gave us was 37. I'm just going to put 40 in case I want to go a little bit past that. Y minimum, the minimum amount of consumption they gave me was 12.4. I'm going to go a little below that. I'm going to say my minimum is 10. Maximum, the maximum value of consumption they ever gave me was 22.6. I'm going to go a little above that and say 24. But you shouldn't struggle with making a window for regressions. The info is there. You can look at it and see minimum and maximum values. If you then hit graph, you should get something that looks perfect like this. A beautiful little cubic function. If you don't see a cubic function, there's 2 things that probably went wrong. Number 1, you mistyped it into your calculator at some point. The second thing that might have gone wrong, your window is out. And if your window is wrong, you might see nothing. You might see a straight line. You might see a quadratic. You could see all kinds of things. So please, if you don't get it on your first try, check those 2 things before you try again.
Do they normally tell you what it is, or we just
Typically,
guess it?
in my experience, which isn't that much experience, is that they do tell you. So they say like create a cubic regression, and they make it pretty straightforward. They try not to make that the tricky part. Okay. Our job was to find a y value given an x value. Your calculator does that really, really easily. You just have to hit trace. As soon as you hit trace, your calculator now will allow you to enter an x value. So you go 22 and then hit enter. And it'll show you right on your calculator x equals 22 when y equals 20.1. Now the question was, according to the, oh, sorry. Oh, yeah, no, that's good. Cool. I just read the question backwards when I looked down and I was like, oh no, I did everything wrong. So that means the consumption rate in 1992 was 20.1 quadrillion BTUs. All right, question C. According to your model, what would the United States consume when would the United States consume 17 quadrillion BTUs? We're going to just make that when's the first time they would consume 17 quadrillion BTUs. Because sometimes there's multiple answers. And it would definitely specify, say, the first time. Or when's the last time that they consume that. We're looking for when. That means we're looking for a year, which was X. That means they must have given me a Y value. They did. They gave me a Y value of 17 quadrillion BTUs. So what you need to do is go back to your beautiful graph. You need to draw a line at Y2, 17. And that's going to draw a nice horizontal line at all the places that there's 17 quadrillion BTUs. The line goes right here.
Oh, and then
Yeah.
that's not that bad.
And it does only touch our graph once, which is perfect because it makes our life way easier instead of having to figure out which one it wanted. You'll notice when you look at your graph, the green line is the rate of consumption. The red line is 17 BTUs. You want to figure out where they cross each other, right there. Second, trace, intersect. Do not use your up and down arrows when you're doing questions. Use your left and right arrows. So second, trace, intersect. Using my left arrow, I'm moving my calculator, my screen all the way over to where my star is. I then hit enter 3 times. Enter, enter, enter. And it tells me that at 3.14, I have 17 million as my Y value. The question was, when would the United States consume 17 quadrillion BTUs? The answer is not 3.14. 3.14 represents how many years since 1970. So what you want is 1970 plus 3.14. That would be the year 1973 plus 0.14. You don't need to worry about that decimal. It happened during 1973. Remember, we don't need to round, right? So 1973 represents the start of 1973. The 0.14 represents that it's probably around January or February that it was in 1973.
What is a BT? Like this question, what is this like?
Is gas consumption? I think that's just how they measure the flow of gas. Like, when when you have those things outside of your house that measures how much gas is going through. I think that's just their way of measuring something. It'd be like liters. And, you measure your milk in liters. They measure gas using BTUs as their measurement. It's told to us. If you're watching a video, British thermal unit. That's what it means.
I was like, is it Bitcoin maybe?
Yeah, Bitcoins, like the 1973 Bitcoins. Awesome.
Bitcoin was cheap back.
I wish I bought Bitcoins when they were cheap.
Is Bitcoin like actually money?
So that kind of concludes our polynomials idea. So there's going to be a lot of word problems, probably a lot of graphing and interpreting graphs. The other side of polynomials was sinusoidals. So sinusoidals were those wavy graphs. We use sinusoidals for any time that you have a cycle of some sort, like the sun, right? The sun goes up, it goes down, it goes up, it goes down. It keeps repeating over and over and over again. Things we've seen in the past is like Ferris wheels. They go round and around, up and down, up and down, up and down. The temperature is cyclical, right? It's cold in January, warm in July, cold in January, warm in July, and it switches every year. Yeah, minus 41 week. Yeah, exactly. Even during the day, like your temperature is cyclical, right? It gets warmer by noon, colder by midnight. Warmer by noon, colder by midnight. Depends where you are, I guess. Anything that's cyclical, you want to do a sinusoidal graph because that will represent the cyclical nature of that question. There were certain terms that we needed to know. The first term was amplitude. For the record, amplitude we refer to as our A value, which we'll talk about in a bit. The amplitude is the distance from the top or bottom to the middle. So distance from top or bottom to middle. If you're looking at a graph, that means, come on, you can do it. That means from here to here is our amplitude. It's also the same distance as here. Actually, I don't want to put it there. Here to here. Those are the same distances. That means they're both your amplitude. Second thing that we need to do is calculate your period. Your period is on your formula sheet. I think it's in your bottom right. Yeah, bottom left. Your period formula is on the bottom left-hand side of your formula sheet. On your formula sheet, it'll tell you that your period equals 2 pi divided by something called your B value, which we'll talk about in a bit. Your period is how long something takes to repeat or cycle. How long? I feel like you're losing your mind. How long it takes to cycle. Sorry for some of those, but my computer lags, just doesn't do a good job. So your period for this question, what you want to do is look at your graph and find 2 points that are the same. So for instance, looking at this graph, this point right here is the same as this point right here. They're both x-intercepts that both go up afterwards. The distance from that to to that is my period. It's not your B value, it's your period. That's how long something took to cycle. This thing cycled after 2 pi. It might also help to remember amplitudes are Y values, periods are X values, right? If you're thinking about distances. The third thing we want to learn, a horizontal phase shift. You really don't need to know too much about horizontal phase shifts. They relate to something called your C value. Okay, and it moves the graph left or right. Like I said, I don't think you'll really need to. You'll never have to calculate it. I can tell you that much. The worst thing that would ever happen is they give you a question, and then they want you to move the graph left or right. And they'd say, what value needs to change? Your C value would need to change to move a graph left or right. I highly doubt you ever get a question on it. Your midline. Your midline is your D value. It's always Y equals something. So it's a horizontal constant. It's also your average. And that is important. Remember, we did a lot of questions where it said, what's the average height of the passenger on that ride? And you would be like, oh, I don't know what the average height is. Like, how am I supposed to figure that out? And it's just asking for your midline. It's a fancy way of asking for it. Looking at this graph, your midline would run right through here. That would be Y equals 0. Wonderful. We also had a couple, let me just see if it's on the next slide. I don't think it is. We had a couple, oh, it is. Look at that. We had a couple formulas that weren't on our formula sheet that we used to help us out. Those formulas had to do with your amplitude. So your amplitude is actually equal to your maximum value minus your minimum value and then divided by 2. That's not provided to you, but it could be a useful piece of information for you. And your midline is equal to, I want it green. Your midline is equal to your maximum plus your minimum divided by 2. Might be handy if you just forget how to find something. All those values, your amplitude, your period, your phase shift, and your midline came with A, B, C, and D values, some sort of relation to them. We combined all 4 of those things to create this, which is called our sinusoidal function. That also is provided to you on your test. So you never need to know where the A, B, C, D all go. It is provided on your formula sheet. It's right beside your period formula. All right, let's do some questions with this. Sample 3. The function provided estimates the average monthly temperature of a northern Alberta community where T is the temperature in degrees Celsius and X is the month of the year, such that the entire month of January has elapsed at X equals 1. The entire month of February has elapsed at X equals 2, etc., etc. Then they give you the equation. T equals 23.58 sine 0.51x minus 1.79 plus 2.345. Graph this equation with an appropriate window. Graphing this thing. Everyone knows how to put this into y equals. We'll talk about it anyway. So you clear out anything in your y equals. You're going to go 23.58 sine 0.51x minus 1.79, close the bracket, plus 2.345. Awesome. Second thing you need to do when you're graphing these things is you need to be in the proper mode. Remember that if you weren't in the proper mode, you usually just got straight lines or crazy things, right? It was like up, down, up, down, up, down, up, down. To graph a sinusoidal, hit mode, you actually want to switch into radian mode instead of degree mode. Step 3, you need to set an appropriate window. We're going to talk about this window for a second. So we have X minimum. In this question, X is the month of the year. So the minimum number of months in a year you could have would be, 0, the very start of the year. The maximum, X max number of months you could have in a year would be, you could put 13 so you see one past it, just in case you need a little extra room, which wouldn't be a bad idea. You could also put 12 if you just want to see exactly 1 year. You could put 24 if you want to see 2 years worth of rotations, which might also be handy. I am going to put 13. The reason I'm going to put 13 is because then I can see the entire first year. I can see a little bit past it if I need to. X scale, again, we leave it as 1. Y minimum. Now, I am definitely a fan of just using your brain to set y values. So if you think about the question and logically, what would be a good minimum temperature, because y is temperature in this question. Now, if that doesn't work for you, if you're like, I don't know, in the context of this question, I don't know what a good minimum would be. There is a trick that you could do. Does anybody remember that trick? Pardon? Zoom fit, please, Lord, don't do zoom fit.
Honestly, I'm not gonna lie, I zoom fit and then I adjust the zoom fit just to give me a general idea of where I'm supposed to be, and then I adjust the zoom.
Oh, Lord, help us all.
Yep. That's what I'm not doing on this class.
It's like you see it, and I look for it.
Oh, there's a trick that will give it to you spot on. Yeah, you're really close. So if you look at your equation tells you things. Your amplitude tells you the distance from the middle to the bottom or middle to the top. Your D value tells you the middle. So if you want to find your minimum possible value, then if you take the middle and subtract the amplitude, that will actually tell you exactly where the minimum is. In this case, 22.345 minus 23.58 tells me that my lowest value is negative 21.235. So a good minimum would be negative 22 degrees. You can use the same trick to get your Y maximum, except instead of doing your average minus your amplitude, you're going to do your D value plus your amplitude. So you're going to do 2.345 plus 23.58. And that'll tell you your maximum temperature is 25.925. For our window's sake, we're going to say 26. With sinusoidals, there's no real need to guess, especially if the equation's given to you. The answer's right there. You then hit graph. You should get a graph that looks like this. That red line represents the average temperature at any given moment in the year, starting with January 1st. Makes sense because it's really cold. Then it warms up, gets hotter. Halfway through the year, about July, June, it's super hot. Then it gets colder again as we get closer to December. And if you did 24 as your X max, you would see it repeat that exact same pattern. So right now it looks like a quadratic almost, right? But realistically, if you looked at more X values, it would just keep doing that pattern over and over and over again. So that's what temperature does. It goes up and down over and over and over again. Question B, what is the warmest month?
Summer.
All right, it's definitely somewhere in the summer, right? This probably wouldn't be a good diploma question because you could probably guess June or July and get it right. What's more likely is they do the same question but with days of a year. So then you have 0 to 365, right? And that's harder to guess that year. Yeah, try to split it. Like probably like the 183rd day, like somewhere in there. For us, the warmest month, they're asking for that right there, that blue star, that maximum value. To find maximums, you go second, trace maximum. Second, trace max. You go left of that maximum. You hit enter. You go right of that maximum. You hit enter. And it gives you an answer of 6.58, 25.9. X represents the month. Y represents the temperature. The question will define how you read those X values. So it told you that the month of January has elapsed at X equals 1. So that means all of January was 0 to 1. February was 1 to 2. March was 2 to 3. April was 3 to 4. May was 4 to 5. June was 5 to 6. July is 6 to 7. 6.58 lands in July. Just be aware of how they define things for you. I doubt they make you do that. Again, they've gotten better at making the diploma less about tricks like that and more about just knowing how to do the math. But you should be able to read how it works. You're right, 6 is June. Like the 6th month is June. But the question told us that the entire month elapses at each number. So that means when it was at 6, that's the last day of June. I know, we don't have time for any of our Parks and Rec games anymore. I'm sorry. I'm sorry. Maybe we sneak one in at the end. Our coldest month. Our coldest month, ladies and gentlemen, your coldest month is one of these months over here. Because it's cyclical, it doesn't matter which one you find. One of them might be beyond 12 months, and then you'll have to use a little bit of logic to figure it out. And one of them might be negative months, which means you have to use a little bit of logic to figure it out. I'm going to find the front one. So to find that minimum value, I'm going to go second trace minimum, number 3. I go really far left, off my screen left, and then I hit enter. And then I come to the right, and I hit enter. And I get a minimum value of 0.42. That would be the month of January. Awesome. That's interpreting a sinusoidal graph. Part C, what is the average temperature of this community? That's one of those questions where you just need to realize average equals your midline, which equals your D value, which is 2.345. Getting asked the average is the easiest thing you could get asked on the diploma. I truly feel that way. You just have to know that average is midline. I hope they ask you that. because it really is like 2-second question. You know the answer.
Okay.
Average, midline, done. Right? I wouldn't put that on there. I'd make it too hard. Part D, what is the period of this function? There's different ways to do it. If they give you the equation, which they gave you the equation, then I would just use our period formula. Our period formula is 2 pi divided by b.
It's gross.
B is 0.51. If you put that in your calculator, 2 pi divided by 0.51, you get a value of 12.3 as your period, which makes sense because we say that period is how long it takes for something to cycle. How long would it take for temperature to cycle? 12 months, right? 1 year. That makes a lot of sense. The 0.3 means there's probably some sort of rounding error in this equation. Right? It's not a perfect model, just a good enough model. Awesome. That's interpreting a sine graph. Then, yeah. Yep.
No.
We can. Okay, so example 3 was given a sine equation. What do you do? Example 4 is given a sinusoidal graph. What do you do? If you're given a graph with no points, then you just have to interpret the graph. You're not going to be able to create an equation because you're not going to be able to find the C value. So all you have to do is read the graph to answer every question. It says the height of a Ferris wheel ride is represented by the graph below. It's represented. How long does the Ferris wheel ride last? Okay. The Y value is telling me the height of my Ferris wheel. T is giving me how high I am on the Ferris wheel at any given time. So I start here, and then I'm riding the Ferris wheel, and then it stops. So how long did the Ferris wheel ride last for? It lasted for 10 minutes.
How big is your team?
65. All right. Ladies, we don't have long, so just bear down. 2 minutes, please. Part B. If Jimmy can only see his friends when he is at least 10 meters in the air, for how long can he see his friends while on the ride? What you need to do is figure out where he's 10 meters in the air or higher. Right? So, for instance, this line I'm about to draw is 10 meters in the air. If he's ever above that point, then he can see his friends. If he's below that point, he can't. So from here to here, he can see his friends. That is 2 minutes. Right? 2 minutes. But then from here to here, he can see his friends again. That's another 2 minutes. And then from here to here, he can see his friends. That's another 2 minutes. He can see his friends for 6 minutes.
So that line you drew at 10, would that be the midline or the average?
It is, but that's a coincidence, right? It's a coincidence that they chose 10 meters as the midline. They never asked me to draw the midline. They asked me to draw 10 meters, which is the midline. Part C. What are the amplitude and period of this function? Amplitude is the distance, it's the A value, but we're not given an equation on this one. So this time, instead of using the number definition from our formula, we need to use the actual definition of what amplitude is. Amplitude is the distance from the top to the middle. My middle, if you can't see it, is 10. I know it's 10 because then the gap from the top to the middle is 5, but the gap from the middle to the bottom is also 5. And it has to be the same, right? You had to split that graph in half. So the amplitude A is 5. You also could have gotten that by taking the maximum value of 15, subtracting the minimum value of 5, and dividing by 2. The period. The period equals 2 pi divided by b, but we don't know what b is. So what we need to do is look at this graph and realize period is how long it takes for something to cycle. In this question, this is the distance of one cycle. Right? 2 spots on the midline that both go up after. That distance is 4 minutes. That means my period is 4. It's almost like a guarantee you get some sort of real life context sinusoidal question. We're going to do a couple more on Tuesday. So a reminder of what your lives look like. Tomorrow we're doing a field test diploma exam. Be here early. On Monday, you are doing not a practice. You're doing like a second midterm, right? The last 3 units. It's your opportunity to reassess those 3 units.
Is it the same as like it won't affect your grade?
It won't affect your grade. It can only increase it. It's basically a free reassessment, but it's also a free look at how well you're doing. So I'm going to try to make it to the diploma level challenging. Probably not. I think you'll do great. Tuesday, we'll review the rest of sinusoidals and try to do some logs. And then Wednesday's your diploma.
I decided on